How are you guys? Welcome back to my YouTube channel. We're still under strength of material. This is an equivalent torque and equivalent bending moment n6. And then if you've not subscribed to my channel, may you please become the part of the family by subscribing. Guys, let us reach 1000 subscribers. Let us reach 1000. Feel free to share these videos to your fellow classmates. Help me to reach 1000 subscribers. So guys, so that as you guys, you're subscribing, you give me energy to post some more videos, right? All right, so we've given a business signal. They've given a business signal is placed, as you can see there, it is placed its lower end 4 meter above the level. Why I'm bringing this question is because I've seen this question on typical exam question, the one of the business sign, the signboard, the one your business signboard. I once saw this typical question there on your question paper. So you've given the signboard itself measured by 1 meter by 0.8 as shown in figure 3.10. Here is the signboard. I saw this typical question on an exam question. Does not change, it's become like only change the values, but if you can know this, then you're good to go. If maybe might happen, the examiner throw this question, so that be aware of this. And the one of the guys, and the one that of the crankshaft, hopefully you've watched the one of the crankshaft. The examiner also throw that one on the question paper. You must be aware of those things. So anyways, it's up to you, but the video is here. Okay, so I've given the distance of the center of the sign to the central point of the pole is 0.8. The pole is the outside diameter of that, the inside diameter. If the wind pressure, as you can see, this is the wind pressure, is exerted on this signboard, calculate the principal as well as the shear stress induced in the pole. Look, guys, you're given this. Here we'll have the pressure that is acting there. That will be the wind pressure. Will be acting on the board, as you can see there, guys. We'll have that. All right, will act there. So how do we find pressure? We get pressure. We know that pressure, but this is a pressure, wind pressure. This wind pressure will be equals to what? We know that the pressure is equals to force over area. How we can find the is equals to what? Force over area. Now will be what? The force of the wind divided by area of the board. We want what? Let us calculate the area, the force there, sorry. Then the force of the wind will be equals to pressure of the wind multiplied by area of the board. Then they will have the pressure we're given there is 3 kilopascal. So we have there 3 kilopascal is same as times 10⁻³ multiplied by the area. The area of the board, guys, acting on the board, it's a square. As you can see, it's a rectangle, is 0.8 multiplied by 1. All right, 0.8 multiplied by 1. Force of the wind will be 2.4 kilonewton. All right, we have that the force of what? Of the wind. This is simply the force of what? Of the wind. So we have that force of the wind. Let us find the torque. This is the step that you're supposed to take. Remember this torque here, because there is a force that is acting there. Since there is a force, let's find the what? The torque of the wind. The wind torque. Torque wind will be what? Force of the wind. This typical question, you will answer it like this even during the exam. Multiply by what? By your x distance, part of what? On the board, the x of the board. where is the part here, talking about the x going like this, it's x. The x is the one that will be given. I'm talking this distance like that, it will be your x. On the part there, we know that the force we've calculated 2,4 times 10 to the power of 3 multiplied by 0,7. This will give us 1,68 kilonewton meter. Alright, that is the torque. Then the aim, you remember, the aim is to calculate the shear stress and what. Remember, we're supposed to have TE, it's equals to maximum bending moment plus what? Maximum torque. So we have the torque we've calculated. Now we're left with to calculate the maximum bending moment, the bending moment. So we have the torque. Now let's try and calculate the bending moment. You know that it's wind that is applied there multiplied by the force of the wind. We know that bending moment will be multiplied by the wind multiplied by y. This is what you're supposed to know, will be like this. Even on your exam, we know that the force of the wind is 2.4 times 10 to the power of 3, but y is from the start point here, that is the start point, going up from the start point like that, going up until to the center of the board, until to the center of the board. You will have what? Till to the center of the board, until is y is from here where the start point until to the center of the board. So what will be that y? From the center of the board here until here, that is our y. So will be 0,5. The half there, when you divide 0,8, will have 0,4. Also the top will have 0,4 there. So this will be 4 plus 0,4, because we want the half of that. The half of 0,8 will be 0,4. Now we add 4 plus 0,4, 4 plus 0,4, or you can simply add it same time. This is the same as 4,4. Then when you multiply that, what will be 10,56 kilonewton. Obviously it's measured in kilonewton meter. We have now this. Now we go to equivalent torque. We know that it's the maximum bending moment plus torque squared. So we have this now, so we can substitute TE square root of this. You know that we got this to be 10 like this. Bending moment, the torque, it was 1,68. Square this, we'll have this to be 10,693 kilonewton meter. So now we have this. All right, but the one principal stress we get it from that, guys. Principal stress for equivalent bending moment. Principal is only, we get principal stress here on the equivalent bending moment. So considering equivalent bending moment, we know this is 1/2, like this. All right, so we have 1/2 TE. Take note, TE, we know we have calculated TE. TE is the same as that one, guys, square root of that. We've calculated there on the top what TE. Okay, and the moment is still 10,56 plus TE is the one just calculated there is 10,693, but obviously those will be in kilonewtons because we substituted this in kilonewtons. So our answer, since this is in kilonewton, our answer must be in kilonewton also. All right, we'll have 10,626 kilonewton. So we have now this. What can we do now? Since we have this now is good. We want the principal stress. Also, we need the shear stress. Now we know that shear stress can be given by 16 TE. Actually, make TA the subject is from the formula of TE. You remember from our formula there. So we make it the subject of the make TE the subject of the formula. The stress there multiply by that. Multiply by our diameter divided by pi. Remember that it's a hollow diameter, will be like this. Small letter d here, raised to the power 4. They said it's a hollow diameter. Remember, we have 16 TE. We did calculate, we stole this value 10 comma something there, 10 comma 9, 10 comma there we have 10 comma 693. Obviously it's in kilonewtons. That thing, it's in kilonewtons. All right, we know that it's in kilonewton times 10 to the power. It's in kilonewton per meter. It's in newton per meter times 10 there. Power of 3 like this. Then what is the diameter? We go to a value. They said the diameter, the outer diameter is 100, the inner is 8. So we have 180. 100, the outer will be 0,1. When you divide by 2, divide now pi, the outer is still 0,1 raised to the power 4 minus 8 is the same as 0,08. All right, raised to the power 4. Punching this, we should get our shear stress to be 92,239 megapascal. Then principal stress, guys, principal stress will be 32 multiplied by ME multiplied by diameter multiplied by pi over d raised to the power 4 minus d raised to the power 4. From this equation, guys, we know that ME actually is equals to pi multiplied by the d raised to the power 4 minus d raised to the power 4 divided by 32. So we just make multiply by the principal. Just make the principal the subject of the formula here. So do not be amazed there. You get from this formula. If you make that the subject of the formula, you're supposed to get this if you do the subject of the formula. Then your principal stress, this is simply what our principal stress if you have ME, guys, will be principal. Once you see this ME, just know that it's the principal. If you have equivalent bending moment, this will be principal. Let me denote it by P. This is the principal stress. All right, this is the principal stress. Then we have 32 ME. We did calculate it there on the top. We got that to be 10,626. Obviously was in kilo times 10 power of 3 multiplied by big D. We said is 100. You'll say me 0,1 divided by pi 0,1 raised to the power 4 minus 0,08 raised to the power 4. That was the inner diameter. Then our principal stress will simply, when we punching this, supposed to get that principal stress must be 183,333 megapascal. So this is what you will have there. All right, this is what you'll have. Okay, guys, thank you for watching. May you kindly subscribe to my YouTube channel. Let us reach 1,000 subscribers, guys. Help me to reach this value. It's obviously, as long as I did not reach 1,000, remember, guys, YouTube won't pay me nothing. And then, you know, I'm just recording these videos. There's nothing that I obtain, just for you guys, so that you'll be good. So do me good, just subscribe there. All right, just subscribe, so that show you charity by subscribing, show you humanity there. Subscribe as I bring in this video for you guys. All right.